Good afternoon, class. We are looking at Chapter 8, Further Applications of Trigonometric Functions, Section 8.1, The Law of Sines. So in this chapter, Chapter 8, Further Application of Trigonometric Functions, we are going to look at the law of sines, the law of cosines, polar coordinates, equations and graphs, polar form of a complex number of polar form of complex numbers, the complex plane de Moivre's theorem, and vectors. The objective of this section is to solve SAA, meaning side angle angle, ASA, angle side angle triangles, solve SSA, side angle triangles, and solve applied problems. Recall properties of trig functions, fundamental identities. We remember a unit circle having equation of x squared plus y squared equals 1, and a point P having coordinates x comma y. X is cosine and y is sine. Some of the fundamental identities that we should know: Pythagorean identity, sine squared plus cosine squared equals 1. There are two more. Quotient identities, tangent is sine over cosine, cotangent is cosine over sine. Reciprocal identities, cosecant is 1 over sine, and the rest of it. A periodic function repeats its values at regular intervals. Trig functions are periodic, k is an integer, and all of them have 2 pi as a period, except tangent, which is pi. Therefore, for example, sine of theta plus 2k pi is sine of theta. Tan of theta plus k pi equals tan of theta, just as an example. Even and odd properties. Even function means f of minus x equals f of x. Odd function means f of minus x is minus f of x. All trigonometric functions are odd functions except cosine, where cosine of minus x equals cosine x, and secant goes with cosine because it's the reciprocal of that. So secant of minus x also secant x. When you have a right triangle, one angle is 90 degrees, and the other two, a plus b, must add up to 90 degrees. And according to Pythagorean theorem, a squared plus b squared must be equal to c squared, where c is opposite the 90-degree angle, the hypotenuse is the largest side. Double angle, half angle, and so on. Remember the sum and difference formulas. For example, sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. And tan of alpha plus beta is tan of alpha plus tan of beta over 1 minus tan alpha tan beta. And they will result in double angle. For example, if you recall, we can replace this with alpha. We get sine of 2 alpha is 2 sine alpha cosine alpha. Cosine has 3 different ways. Equalities: cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared. And tangent is 2 tan alpha over 1 minus tan squared alpha. Now, in each case, we can solve for sine squared. In this case, for sine squared. In this case, for cosine squared. So sine squared from here gives us 1 minus cosine 2 alpha over 2. And if we cut this in half, we cut this in half. Cosine from here, cosine squared becomes 1 plus cosine to alpha over 2. Cut this in half, and this becomes alpha. And tan squared alpha would be the ratio of sine squared over cosine squared. And if you cut this in half, we will cut this in half. So it gives rise to half angle formulas. For example, the sine of alpha over 2 squared is given like that. Sine of alpha over 2 is plus minus the square root of 1 minus cosine alpha over 2, and the rest of them follow. What matters is that you decide which, sign, positive or negative, based on the quadrant they belong to. And product to sum and sum to product formula, for example, sine alpha sine beta is half of cosine alpha minus beta minus cosine alpha plus beta. You can get this using sum and difference formulas. If you put these two together, you can see sine of alpha plus sine of beta accordingly. Of course, subtract one from the other. Also, when we looked at the right triangle, we said two angles add up to 90 degrees, and a squared plus b squared equals c squared, and this is considered angle theta, okay? And we have the following. Sine of theta is the opposite, which is b, over the hypotenuse, which is c. Cosine theta is the adjacent to theta, which is a over the hypotenuse, which is c, and the rest of them follow. Remember, sine tangent is the opposite over the adjacent, b over a, and the rest of them are the reciprocals. Angle of elevation and depression. Definition. Angle of elevation is the angle formed by the line of sight and the horizontal plane for the object above the horizontal. So this is angle of elevation. Angle of depression is the angle formed by the line of sight and the horizontal plane for an object below the horizontal. Bearing. A bearing is used to represent the direction of one point relative to another point. Method 1. The direction or bearing of a point is the number of degrees in the angle measured in a clockwise direction from north or vertical line to the line joining the center of the compass with the point. So, for example, this is just 65 degrees. This is 300 degrees. Method 2, direction or bearing of a point O to a point P, O to point P, equals the acute angle theta, has to be between 0 and 90 degrees, between the ray OP and the vertical line through O, the north-south line, either north or south. So for example, this one would be north 30 degrees east, whereas this one would be north 70 degrees west. And this one closer to south, south 50 degrees west, this one south 20 degrees east. That's the synopsis of what we've covered, and now the law of sines. Solving oblique triangles. Oblique triangles meaning none of the angles is a right angle. So we could have all of them to be acute, meaning less than 90 degrees, or one of them obtuse, meaning more than 90 degrees, and the other two must be smaller than 90 degrees. So two acute angles and one obtuse. All angles are acute. Acute means A is between 0 and 90 degrees. Obtuse means, in this case, B, between 90 and 180. It's larger than 90 degrees. So if you happen to have an oblique triangle, normally you can draw it and it doesn't have to be to scale, and then you figure out the scale after you solve it. So this is vertex A. Across from it is side lowercase a. Vertex B, capital B. Across from it, side lowercase b. Vertex C, across from it, side lowercase c. Then the sine law says sine A over A equals sine B over B equals sine C over C, or you can even write the reciprocal where A and B and C, they add up to 180. So that is the sine law. Cases of solving oblique triangles, none of the angles is a right angle. How many cases do we have? Well, we have ASA. Remember, A stands for angle, S stands for side. So that means we have two angles and the side in between. SAA, we have one side and two angles, and that side is not in between. SSA, we have two sides and some angle not in between. In between is called included angle. SAS. So seems to be similar to that. The difference between these two, this angle is not in between. In this case, the angle must be in between. Side, angle, side is called the included angle. And finally, when we have three sides known. So these are various cases. Case one. We have ASA and SAA. So ASA, angle, side, angle, and SAA, side, angle, angle. One side and two angles results in one unique solution and one unique triangle. We end up with one solution we can solve. Now, solving oblique triangles, case two. Case two, we have SSA. We have two sides and some angle. SSA, side angle. That means two sides and an angle opposite one of them. It's not in between. It's not the included angle. That's the key. Could result in several different situations and solutions to occur. Consequently, SSA is referred to as an ambiguous case. If A is acute, the side across it, lowercase a, is equal to the H, we have one triangle. Of course, it's a right triangle. If A is acute and A, this side, is larger than B, this side, and it's larger than H, we get to one triangle again. If A is obtuse, that means between 90 and 180, and A is larger than B, one triangle. By the way, A must be the largest side anyways, because the larger the angle, the larger the side opposite that angle, okay? If A is acute and A is less than the height H, no triangle exists. If A is obtuse and A is less than or equal to B, no triangle exists. Finally, in this situation, A is between H and B. Since A is larger than H, a triangle is created. But since A is smaller than B, it can swing to the left of H and create the second triangle containing an obtuse angle, meaning there's a possibility of having two. So A, this one could be A, or this one could be A. So there are two possibilities. So one solution, no solution, two solutions. We will look at all those examples. Solving oblique triangle case number 3. SAS. SAS side, angle side, two sides, and the included angle, meaning the angle in between, results in one unique solution and one unique triangle. Solving oblique triangle case number 4, SSS. SSS, side, side, side. Three sides results in one unique solution and one unique triangle, as long as one side is smaller than the sum of the other two sides, and we require cosine law to solve this. So it will have no solution if one side is larger than the sum of the other two. Remember, every side, for example, this side must be smaller than the sum of these two. As long as this is the case, it will have a unique solution. The law of sine, we are going to look at the proof of the law of sine that was mentioned, sine A over A, sine B over B, and so on. You can put this as sine A over A, sine C over C, sine B over B, sine C over C. Ultimately, you put all of them together. So you have this oblique triangle. We have vertices A, B, C, and the sides lowercase a, b, c, opposite each vertex. We drop a perpendicular, and this distance is h. So in this, if we look at this triangle, sine of this angle is the opposite h over the hypotenuse. For this small side, h over c, sine b is h over c. For this one, so H becomes the product of these two, C sine B. It's the cross product, everybody. Now let's look at this one and let's look at this angle, this one. In this case, sine of this, sine of C, is the opposite, which is the H, over the hypotenuse for this one is B. And again, let's do the cross product. H becomes B sine C. And so these two must be equal. Let's divide both sides by BC. So if you divide by BC, this one drops, this one drops. We get sine B over B equals sine C over C. We prove this one. Let's repeat the same process with the altitude drawn from a different point. For example, point B. So that means you drop a perpendicular from here. If you look at this small triangle, and if you look at this angle, sine of this angle is the opposite over the hypotenuse. Hypotenuse is opposite than 90 degrees. Remember, this is 90 degrees, so this is 90 degrees. So the hypotenuse would be C, H over C. And again, cross product H equals C times lowercase c times sine A. Let's look at this one. Again, a right triangle. Right triangle. And for this angle, the opposite is this. And the hypotenuse is opposite the 90 degree, which is A. So sine of C is H over A. And again, we can do the cross product. H equals A sine C. So these two must be equal. And we are going to divide both sides by AC. When we divide both sides by AC, the C drops here, the A drops here, and we get sine A over lowercase a equals sine C over lowercase c. So we prove this one, we prove this one, and of course, because this is in common, this is also equal to that, and that's the sine law. Normally we put sine A at top, A at the bottom, but even the reciprocal works out. So sine A over A equals sine B over B equals sine C over C. Again, the reciprocal works out as well. But normally this is the way we write. By any chance, if we wanted to prove this one individually, we would drop a perpendicular this way to this side lowercase c, and we will achieve this one. No need. We have these two, put them together, you get this. Using sine law to solve side angle triangles, solve the triangle A equals 40 degrees, B equals 60 degrees, A equals 4. By the way, they have given us the triangle. Even if they haven't, I highly recommend you draw something, and it doesn't have to be to scale. Ultimately, remember, the smaller the angle, the smaller the side opposite that. So clearly, if one is 40, one is 60, okay, the fastest way is to get to the last angle because they add up to 180. So 40 and 60, 100, subtract from 180, you get 80. So this is the smallest angle, and therefore is opposite that. And then opposite 60 must be larger, and opposite C must be larger. So first and foremost, this angle C, so just for the sake of argument, let's just do this. So this is A, capital A, capital B, capital C. And so we get 100, we get 180 minus 100. This is 100, everybody. Or 80 degrees. So we have this angle now as 80 degrees. So we have all the angles. To find the side, we are going to go with the sine law. Even if they don't mention sine law, that's the one we are going to use anyway. Sine A over A equals sine B over B. And always try to use the given rather than the one that you've calculated. Although we've calculated this, we don't want to take a chance. You always stick with the ones that are given if possible. In this case, sine 40 over 4 equals sine 60 over B, because B is missing. So obviously the cross product means 4 times sine 60 is equal to sine 40 times B. And so B becomes 4 times sine 60 divided by sine 40. Again, the same thing for sine of 40 over 4 equals sine 80 over C, and 4 times sine 80 equals sine 40 times C. So it's the cross product of those two. And Obviously, we use this one because it's no. Okay. So using this one, we get to B. Using this one, we get to C. B is 4 sine 60 divided by sine 40. You have to put this into a calculator because sine 40 is not a common angle. This is square root of 3 over 2. We know that, but anyway, so this, we know it to be square root of 3 over 2. So you put that into a calculator, and normally you go with 1 or 2 decimals unless otherwise mentioned, because A is given as a whole number. Most of the time you go with only 1 decimal, but follow the instructions. So let's say we want to go with 2 decimals. Next to this is 9. We change it to 5.39. That's an approximation. Um, Again, let me just, I hope everybody knows this, that when we do the cross product, okay, we get B times sine 40 equals 4 times sine 60, and that's easily understood. Now, so the same thing here, 4 times sine 80 equals C times sine 40, so C would be the product of these two times divided by this. So this is 5.39, and now this is the value of C. We put it into a calculator again, and we approximate it with a couple of decimals, and we replace this, and this is a solved triangle with all the answers, everybody. Let's look at the next example. Solve the triangle. A is 35 degrees, B is 15, and C is 5. So let's just say this is A, this is C, this is B, based on the given. And so obviously the very first thing we're going to look at is the angle they add up to 50 subtracted from 180. So C is 130. So we have all the angles. We have all the angles. Sine A over A equals sine C over C. So sine A, sine of 35 degrees, lowercase a, missing, sine C, sine of 130 degrees, lowercase c is 5. So cross product of these two is equal to the product of these two. I write it at top of it, and again, just so make sure you remember to do this in one shot. You can say A times sine of 130 is 5 sine of 35 degrees. So divide by sine of 130. So you should be able to go from here to here from now on. You have to use a calculator. So you put this into a calculator, sine of 35 times 5, divided by sine of 130. Using a calculator, you end up with 3.74. And you're going to replace that A with 3.714. We're going to use the same thing here because we have the top and the bottom. But over here, we're going to go with sine B over B. And this way we keep this one the same, right? This one is sine B, sine of 15 degrees over the missing lowercase b. And so the product of these two is the same as the product of these two. So we multiply these two, 5 times sine of 15 and divide by sine of 130. Put it into a calculator. Use a couple of decimals, 1.69. Replace the b with that, and you're done. Solve side-side angle, the ambiguous case. SSA, side-side angle. Two sides and angle opposite one of them. So in this case, side A is given, side B is given, and the angle opposite one of them, in this case, opposite A. Sine of A is H over B. So H is the product of these two, B sine A. if the situation is such that A, this side, is smaller than H, which we proved is equal to B sine A, because this distance is B sine A, then it can't work. There is no triangle. It can't reach the other side. On the other hand, if this, which is B sine A, is less than A and less than B, so it's less than A on the one hand and less than B on the other, what happens? Here's the A. Think about this. Here's the H, which is less than A and less than B. That means there are two possibilities. We can get two triangles. We can get this one, the big one, or this one. Either the big one or this one. And the reason is this angle and this angle are supplementary. They add up to 180. And sine of this angle is equal to sine of this angle because sine is positive in the first and second quadrant. That's the way it works, and that's the reason. So H is B sine A. We showed that H is equal to B times sine A. And if A is larger than or equal to B, then this H, which is B sine A, there is no way to have more than one triangle. So A is equal to H equals B sine A, in which case we have one triangle. And when A is equal to H equals B sine A, it's a right triangle. Either way results in one answer. So that's why it's called the ambiguous case. We come up with different situations. So let's look at an example of this, everybody. Using sine law to solve SSA triangle, and this is case one. Solve the triangle when A is 3, B is 2, A is 40 degrees. And usually you draw a triangle, they have given it to us, but it doesn't have to be to scale because we may not know what's going on. And then as we solve the triangle, we make it more precise, okay? This is A, because this is lowercase a. And this is C. Those are the vertices. So sine A over A, sine of 40 over 3 equals sine B over B, sine B is missing, and B is 2. So cross product, meaning 2 times sine 40 is the same as 3 times sine B. I'm going to write that at top. And again, just to remind you, you don't have to. You should know by now that sine B is 2 times sine 40 divided by 3. But let's write that 3 sine B is 2 sine 40. And therefore, sine B is 2 sine 40 divided by 3. We should be able to go from here to here. By now, we have seen it a couple of times, and it should be pretty obvious. And of course, you use a calculator, you end up with 0.43. So if it's 0.43, what is B? Sine inverse of 0.43. I'm going to call it B sub 1 in a moment. You'll see why. But for now, B or B sub 1 either way is fine. So what do? You put it into a calculator, and you get 25.4 degrees. B sub 2, the reason I call this B sub 1, because when sine is positive, has two answers from 0 to 2 pi. One in the first quadrant, one in the second quadrant. So the first quadrant acts as reference arc. So to get to the second quadrant, subtract this from 180. Okay, so I hope everybody remembers this, okay? So what happens? I'm going to cross this out. Why is that? The three angles must add up to 180. One of them is 40. If I add just these two, I get 194.6. Can't work. That's why it's out. So that's exactly what happens when you're solving for the sine. One of them is in the first quadrant. That works out. You can figure out the rest. This works out. We figure out the rest. What happens to this one, this may or may not work out. If the sum of these two is more than 180, it's out. In fact, if it's equal to 180, it's out, because then there is no third angle, right? Because the three of them must have a sum of 180. So if this angle and this angle, they add up to 180 or larger than that, that's out. Okay. But if it's less than that, let's make up some numbers. For example, 120 and 40 is 160. That's good. This will create this second triangle. Okay. On the other hand, when you get here, if this number is larger than 1, let's say it's 1.1, then it has no solutions. So a quick recap so everybody understands. If this number is larger than 1, sine can't be larger than 1, there is no solution. When this number is between 0 and 1, you have two solutions. The first one that is between 0 and 90 will work, you're done. End of the story, you finish it off. You haven't finished it. The second one, you subtract this number from 180. If this number, adding to the given angle, whatever angle is given, they are 180 or larger than that, it will fade. If it's less than 180, the sum of this and this one, then you have the second one. These are the three cases. All right. So this fails, this is out. What about this one? One angle is 40. One angle is 25.4. Add them up, subtract from 180. So you're going to say the last one, C, is 180 minus A minus B1. That means subtract these two, the sum of these two, and you get 114.6. One thing I want to add, because this is not working out, we're going to call it C, but if it was working out, we would call this C sub 1 and then C sub 2. So that refers to two different possibilities. Now let's go with the sine law. I'm going to repeat this one because we have it. And now sine B over 2, we're going to say sine C over C. Sine C is sine of 114.6 over lowercase c missing. So this is 114.6 degrees, this obtuse angle. Let me erase my work anyway, so it becomes easier to see. So this part repeats, and this part, sine of C, sine of 114.6, lowercase over lowercase c, their product, their cross product means C times sine 40 is 3 times sine 114.6. So C is the product of these two divided by sine 40. You put that into a calculator and use a decimal or two. You end up with 4.24 as the final answer. And so you put everything in. Here's the C. Here's capital C, the angle. Here's the lowercase c, 4.24 this side. And here's the capital B, the angle. And we just solve this triangle accordingly.